Welcome back to Mr. Leek's Free Science Tutorials. This question is then about nuclear fission and nuclear fusion. Two words that then get very kind of mistaken because they sound quite the same and they're both to do with very similar processes. I always think about nuclear fusion. Fusion or fusion, right, is where you put two things together. Right? Two bones or two pieces of metal can fuse together. So, the question is, compare nuclear fission and nuclear fusion. What I've got on this diagram here is the table then talks about the details of it, and then there's two little diagrams at the top here, right, and then we'll actually describe them. So what I'll do is I'll start with nuclear fission. Right? Fission is the breaking up of something, where one large unstable nucleus splits into to make two smaller nuclei. So fission is the breaking up. Now, with a little bit of detail, what you have here is that ball there, right, is just about to go through nuclear fission, and what it does is it splits into two. One goes off in that direction, and one goes off in that direction. Now, the way the nuclear fission actually happens is that little bit of dot there is a neutron. When that neutron hits the uranium-235, it causes the fission to happen. They then split, and you get three other neutrons that are then given off, and two less dangerous nuclei. But with this, what you've got to do is you've got to think about one neutron hits that, and it makes three neutrons. Those three neutrons are then going to hit one of them, which is then going to make 9, which is then going to make 27, etc., etc. That is then how a chain reaction forms, and it's done incredibly quickly. So, nuclear fission. One large unstable nucleus splits to make two smaller nuclei. A neutron hits uranium-235 here. The nucleus absorbs the neutron and splits, emitting 2 or 3 neutrons and 2 smaller nuclei. So that splits, 2 smaller nuclei come off, and it can be 2 or 3 neutrons that are then given off. In that process, energy is also released. Now, if that was just left uncontrolled, what would happen is those 2 or 3 neutrons would then make another and another and another. And like I said before, that would then be a chain reaction. This process is used in nuclear power plants. And the way that we control it in nuclear power plants is we have boron rods. Those boron rods will then absorb those neutrons when we need to slow the reaction down. Nuclear fusion, if you think fuse, putting two things together, right, is 2 small nuclei join to make one larger nuclei. So it's 2 small things come together to make one larger one. It's very difficult to do on Earth because you need huge amounts of pressure and temperature. Now this nuclear fusion tends to occur in the stars. Now when two things do get fused together, what happens then is lots and lots of energy is then given out. So on here we've got 2 substances under huge amounts of pressure and temperature that stars have. They are then forced together, fused together, and you make another element, a neutron, and then lots of energy. So, compare nuclear fission and nuclear fusion. Nuclear fission and nuclear fusion both give out energy. Nuclear fission is when one large unstable nucleus splits to make 2 smaller nuclei. The neutron hits uranium-235 in the nucleus and it absorbs neutrons, splitting or emitting 2 or 3 neutrons. This process gives out energy, and it's used in nuclear power plants. If it's left uncontrolled, it will do a chain reaction, which is basically what a nuclear bomb is. Nuclear fission, or fusion rather, is where you have 2 small nuclei joined to make one larger nucleus. This occurs in stars. It's very difficult to do on Earth because you need huge amounts of pressure and temperature. So, in a nutshell, right, compare nuclear fission and nuclear fusion. Nuclear fission is the splitting of a larger nucleus to create energy. Nuclear fusion is the joining together of two nuclei to make another substance, also giving out energy.